if x squared times y is equal to z cubed, is z cubed greater than 0? So x squared times y is equal to z cubed. So really, they're asking is z cubed greater than 0, but z cubed is, the sign of z cubed is going to be determined by the signs for x squared and y. So what do we know about x squared and y? So x squared, when you square something, it's always got to be greater than or equal to 0. So that means we don't necessarily know the sign of x, but we know x squared has to be greater than or equal to 0. Y can be anything. And so what that means is y is really going to be what determines the sign for z cubed, because if x is positive and y is positive, then z cubed will be positive. If x is positive and y is negative, then z cubed will be negative. And then if y is equal to 0, well then z cubed will also be equal to 0. So you can sort of rephrase this question as is y greater than or equal to 0? So statement 1 says x times y squared is greater than 0. So we're multiplying two things together and we get some value that is greater than 0. So there's only two ways to do that. Either we have two positive numbers or we have two negative numbers. However, y squared cannot be negative. That's not possible. So this option is actually not possible. So what does this mean? So we know from statement 1 that x has to be positive. But like we said, the sign of x is not really what's important. We know y squared has to be positive, but that means y can be positive or negative. So based on that, this statement is going to be insufficient, because we said it is the sign of y that really matters. Statement 2 says y times z is greater than 0. So now here we know either both y and z are positive, or both y and z or negative. But we already determined this. We already determined that the sign of z is determined as the same as the sign of y. So this statement really isn't telling us much different. So this guy here is also going to be insufficient. So if we look at them together now, what do we know? We know x is positive from statement 1. Remember, this statement is sort of irrelevant. And then from statement 2, we still just know that y and z can be, y and z are still either both positive or both negative. And so we can have, if x is positive and y is positive, then z cubed is also positive. But if x is positive and y is negative, then z cubed is also negative. So together, these statements really aren't adding anything. So E.